I really like this Taylor polynomial problem. Please make sure you practice this on your own, even before you even watch this video. I really think you could be successful with this one all by yourself there, okay? And if you need some help, pay attention. We'll explain it to you. I actually have two different ways of how to do letter C. Just whatever way works in your brain there, that's what we'll go with, all right? Now, letter A, okay, so it doesn't really give us a Taylor polynomial or anything like that. It just says P sub n is the nth degree Taylor polynomial. So when it's talking about P sub 1, that's the first degree Taylor polynomial. So it gives us some items and shows what the first derivative is equal to. So I saw P sub 1. That means I was going to find myself a first degree Taylor polynomial. That's what I did here. So I said a first degree Taylor polynomial about x equals 0 is going to be f of 0 plus f prime of 0 x minus 0 to the first over 1 factorial, and then it stops. And then they give us a bunch of stuff throughout this problem. So f of 0, they straight up give us is -4, so I plugged that in. F prime of 0, I didn't know what that was. I was supposed to figure that out, so I can't use that 2 yet. I'm supposed to show that that's equal to 2, and that's just x. And then it gives us a point on that Taylor polynomial. So once you have the equation for your Taylor polynomial, that's your x value, that's your y value. So I took the -3, plugged it in there for the y, took the 1/2, plugged it in there for that x, and I just simply solved this equation for the f prime of 0. I added 4 to both sides, got half of that was equal to 1, multiply both sides by the 2, boom, and I successfully showed that that first derivative was equal to 2. And you got to show all those steps there because you're supposed to show that that's true right there. And what's kind of nice about this problem is that even if you couldn't have shown that in part A, you could still do letter B and C even without that, because it kind of gives you all the stuff that you can use, and you can certainly use the 2 in the other parts of the problem, even if you had trouble doing that. Now, letter B, it tells us to find a third degree Taylor polynomial. So I'm going to start with that main definition of a Taylor polynomial, basic stuff, right? So I did f of 0, f prime of 0, x minus 0 to the first over 1 factorial, f double prime of 0, x minus 0 to the second over 2 factorial, f triple prime of 0, x minus 0 cubed over 3 factorial. That's just your main definition of a Taylor polynomial, like your videos. And then they give us everything that we need there. F of 0, they tell us is -4. F prime of 0, they tell us is equal to 2, and you show that that was equal to 2. And then they just give us the other items. It's nice they don't give us a function. We don't have to take derivatives on this one. They just tell us second derivative is -2/3, third derivative 1/3. So just plug them in. Know your main definition, plug in the stuff, and then be careful with your arithmetic here. I got -2/3 divided by 2. That's the same thing as times it by half to get a -1/3. This is 1/3 divided by 6, which is times 1 over 6 to get that 1 over 18. There's our third degree Taylor polynomial. Now, letter C, I'm going to explain this in two different ways and give each way a shot there. It just depends on which way your brain sees this stuff, all right? But the method one was the first way that my brain thought, and then as I looked at it again, I saw the second way as well. Now, sometimes when they introduce a newer function, sometimes that's intimidating, sometimes it's pretty challenging, but you got to go into there. Sometimes it's actually pretty straightforward too, right? So they're talking about h prime of x is equal to this, blah, 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 blah. They give me some stuff. It says find a third degree Taylor polynomial for h. So if I needed a third degree Taylor polynomial for h, what I started with was a third degree Taylor polynomial for h. I did h of 0. The first derivative, x minus 0 to the first over 1 factorial. Second derivative, x minus 0 squared over 2 factorial. Third derivative, x minus 0 cubed over 3 factorial. Exactly like I did to part B, just did that Taylor polynomial for the third degree. And then what I realized is what I needed was like the first derivative, second derivative, third derivative. It gave me the first derivative, but I didn't have the second or the third derivative. So then what I did at that point, so I wrote this down first, and then I went to the side. They gave me h prime was equal to this. So when I needed h prime of 0, h prime of 0, I just plugged in 0 for that at x. That was f of 0. F of 0 they gave us above, that was equal to the -4. And then when I did the second derivative, I had to take the derivative of this. So this is just like your chain rule thing. You're going to go, the derivative of that is going to be f prime of that 2x, but then you got to times it by the derivative of that inside part. So you got to times it by an additional 2. So when you plug in 0 there, you had 2 times f prime of 0. F prime of 0, that's what they told us was 2. That's what we showed in part A. So then you got 2 times that 2 to get that part is equal to 4. And then that triple prime, you got to do the derivative of this to get the third derivative. So the derivative of that is going to be f double prime of that 2x, but you got to times it by the 2 again, and you already had a 2 out there. That's why it became a 4. And then when we plug in 0, you got 4 times f double prime of 0. F double prime of 0, they're telling us is equal to that negative 2/3. So I get to use that. There's my negative 8/3 right there. So then they told us h of 0 up here was equal to 7. That's how I got that 7 right there. H prime of 0 we found was negative 4. H double prime of 0 we found was 4. H triple prime of 0 we found was negative 8/3. Simplified that. There's my third degree Taylor polynomial representing that h function right there. Some of your brains, and I would pay attention to this because who knows what we're going to have to do. We're just going to get exposed to a bunch of different things there, and you got these tricks up your sleeves where, hey, I could try this, I could try this. What you could also recognize that, hey, since they're giving me a derivative and they're asking me for h, I can integrate the derivative to get the h function there. So that was my second thought, and it works out. Notice I'm going to get the same exact answer here. So what I'm doing for the second part, if they gave me h prime, that means h would be the integral of that. And so up here is what we have is a Taylor polynomial representing f of x. And what I needed was a Taylor polynomial representing f of 2x, because then I could just integrate that. So if this is for f of x up here, all I did was go up here and replace the x's with the 2x. So I had negative 4 instead of the x, I got 2 times the 2x. I have 1/3 instead of the x, I have the 2x squared, and then I got the 2x cubed right there. So I just replaced those x's with the 2x, and then I simplified it there. So I squared stuff, cubed stuff, I simplified it, and then that was representative for the h of x, because I still got my integral symbol there. So that's my h of x. And then I need to integrate this thing now. So it's just easy integrals. And then I realized I went too far here because this was x cubed. So I integrate that, they gave me x to the 4th over 4. But this one is specifically requesting a third degree Taylor polynomial for the h. So I just kind of threw that one out. And then remember, it tells us h of 0 is 7. And so once you integrate it both sides, once you integrate it, you got to put that plus c in there. And it says third degree. So you can stop it at the third degree. You got to put the plus c in there though, and then use that point that they give us. Plug the 7 in for the y, plug the 0 for the x's, boom, the c is equal to 7, plug that back in, and then compare those answers. They're the same thing. So whichever way your brain works there, but practice that problem, group together these Taylor problems, practice them all together. This should be a really good one for us. I'm hoping you got a good chunk of that beforehand, or if you did get stuck and you watch this video, hopefully you realize, oh yeah, I can do all of that problem right there. So good luck with those. Pork chops and applesauce. Great combination.